Good morning, well, be afternoon when you see this. Today we're going to cover tangents and normals, finding the equations of the lines of tangents and normals, and also look at increasing and decreasing functions and stationary points. Okay, starting off then with tangents and normals. It is quite a common application of differentiation that we would have to find the equation of the line for a tangent or a normal to a curve at a particular point. Okay, so I think some of the questions in the last exercise got onto this somewhat. Now, you know what a tangent to a curve at a point looks like. We have that here. The normal, okay, the normal is another straight line that is perpendicular to the tangent at that point and also passes through that point. So we use differentiation to find the gradient of the tangent at a particular point, and if it's the normal that we're interested in finding, the gradient of that line will have the negative reciprocal of the gradient of the tangent. So as always, for a straight line we need the point and the gradient, and we usually get the point from the question, and it was up to us to find the gradient using differentiation. So here, find the equation of the tangent and normal to the curve at y equals 2x cubed minus 3x at the point 1 minus 1. So differentiate the function, we get 6x squared take 3. At A, I've labelled this point A, the gradient, it will be 3 by substituting this in. That is the gradient of the tangent. So if we want the equation of the tangent, we can substitute 3 and minus 1, 1 minus 1 into this equation here to find out and then simplify for the equation of the straight line. Equation of the normal, given that the normal is perpendicular to the tangent, m will be minus a third. And again, we substitute the values in and we get the equation of the line. It's probably best to leave it in this format. Edexcel usually wants you to do that. If it doesn't specify, you can leave it just like this. But it's good practice to know and be comfortable doing this rearrangement. Okay, the second question is essentially the same question. We've got a quadratic this time. We want the equation of the tangent at 211 and the equation of the normal that passes through 211. We differentiate to get the gradient function. At A, x is 2, and so the gradient of the tangent at A is 7. And so the equation of the line, the tangent, is this. The gradient of the normal will be minus 1/7, given that the gradient of the tangent at that point is 7. And as you can see, we substitute 211 into that equation, and we have both equations of the tangent and the normal there. The next thing is, don't just ignore that, I'll set you some questions. Here we've got another straight line, another function, x take root x. It's the exact same process, so if you're ever asked to find the equation of a tangent or a normal, it's always the same process. Find the equation of the tangent using differentiation at the particular point. Take the negative reciprocal if it's the normal that you're interested in, and then use the point to find the equation of the straight line. So that process never changes, even as the functions get more complicated. So here we differentiate, we substitute in x is 4, gradient of tangent is 3/4, gradient of the line is there. The equation of the line is there. Gradient of the normal is minus 4/3. Equation of the line is here. So nothing to worry about, even though the original function was slightly trickier. And that'll do you for explanation of tangent and normal. As I say, the process is the same, never changes. If you want the equation of a tangent at a particular point, say P, you differentiate the function, substitute the x coordinate of that P has into the gradient function, then use the point and the value that you've got for the gradient to write down the equation of a straight line. Do the same process, but must remember to take the negative reciprocal of the gradient at P for the equation of a normal. Alright.